Hello everyone, this is grade 6, module 5, lesson 19, problem set. We see our directions say, solve each problem below. So we're going to zoom in and we're going to take down problem 1, A and B. And I see it says, Dante built a wooden cubic toy box for his son. Each side of the box measures 2 feet. So I'm going to do a quick sketch of this. It's going to be a cube. 2 feet, 2 feet, 2 feet. So now my directions for A says how many square feet of wood did he use to build a box? When I see how many square feet, we're looking for surface area. So I know that for A, I can use 2 formulas for this. Because it's a cube, because it says cubic toy box, I can use 2 times length times width plus 2 times length times height, and then 2 times width times height. Or I can do the one I will use for cubes, which is surface area equals 6 times side squared. So, and the reason why I can use that is all the sides are equal and it's a cube. So I'll do 6 times 2 feet squared. And I know with the order of operations, I have to use my exponents or do my exponents first. I'm going to box that in. And I know 2 feet squared is 4 feet squared. And now I can do 6 times 4 feet squared to get 24 feet squared. So that's my answer for A. Now, B says how many cubic feet of toys will the box hold? So now we're looking at how many cubic feet will it hold. And when I hear cubic feet, I immediately think of volume. And there's 2 formulas for that. I have volume equals length times width times height, which is the one I'm going to be using for this because I see I have a length, width, height. But I could also use base area times height, or area of the base times height. That one doesn't seem to, it will work, but it doesn't seem to work for this one because I'm not given a base area or an area base. So I'm going to use length times width times height. And I know that I have 2 feet times 2 feet times 2 feet. So I multiply this out. 2 times 2 is 4. 4 times 2 is 8. And then I have feet times feet times feet, or feet to the third, which actually means cubic feet. So that's my answer to B. 8 feet cubed, or 8 cubic feet. Now we'll zoom out and we'll head down to 3. A rectangular box of rice is shown below. What is the greatest amount of rice in cubic inches, and that's my vocab, that the box can hold? So immediately, cubic inches implies volume. So I'm going to zoom in so I can get all my work in here. And again, I have 2 formulas, and I see I have a length and a width and a height. Looks a little different than I'm used to, but I know if this is 15 1/3, then this is 15 1/3. So if I'm given length, width, and height, that's the formula I'll use. So volume equals, my length is 15 1/3 inches times 7 2/3 inches times 6 1/3 inches. So now I got to go off to the side, and I'm going to be doing quite a bit of work here because I can't multiply my mixed numbers easily without making them into fractions. So I'm going to make these into fractions greater than 1. And I'm going to use the shortcut for this one because I know I could draw a number bond here showing all 15 branches coming off at 3 to the third, showing that that's equal to 1. And then this is equal to 2, and so on, all the way up to 15. But I'm to the point now where I know that if I am looking for that, I have 15 3/3. So 15 times 3/3, I put 15 over 1, and I'm left with 45 thirds. So 45 thirds is 15, plus my 1/3 is 46 thirds. And I also know that most people use this method. 3 times 15 is 45, plus 1 is 16. And again, that's why that shortcut works. Shortcut's not good if you don't understand it. So the same thing I'll do with the next one, which is 7 2/3. I'm still in thirds, so 7 times 3/3, because 1 whole is 3/3. And that'll give me 21 over 3. And then I got to add in my 2/3 to get 23 thirds. And again, I can multiply and add to get the same thing. And then my last one is 6 and 3/3 again for 1 whole because my unit is thirds for that fraction. Over 1, and I get 18 thirds. That's what 6 equals. Then I just got to add in 1 more third, which is 19 thirds. And we're going to see here that the same thing can be said. 6 times 3 is 18, plus 1 is 19, and that's where my 19 thirds comes from. So I got all 3 of those. Now I need to multiply them. And again, we're talking about inches, so I'm going to slide over a little bit more. And I'm going to take those numbers, and I'll have 46 thirds times 23 thirds times 19 thirds. And this is where your math skills are going to come into play because you got to do 46 times 23 times 19. So I'm going to do that quick off to the side. So there's my calculation there. It took me a minute to do, but I did 46 times 23 to get 1,058, and then I brought that over here and multiplied it by 19 to get 20,102, and I added that. So 20,102, and then this one I can do in my head. 3 times 3 is 9. 9 times 3 is 27. So I'm left with that, and I got to have my units in here because these are all inches. So that's inches cubed. Now, that's an improper fraction, so I'm probably going to want to divide that out and get it back to a mixed number. So that's our long division piece that we have left to do. And that's 20,102 divided by 27. So feel free to go through and do that long division, please. I'm sure you'll have to do it to get full credit. My calculation came out to 744, and then I had 14 over 27. So a remainder of 14, and I'm going to put it over the 27. And that's going to be my volume of 744 and 14/27 inches cubed. So there's my numerical answer. Just make sure you do an answer statement. And let's go to slide 2. So on page 2, we're going to go through and we'll do A, B, C, and D because there's not a whole lot of work involved with this, but there's a bit of reading to do. So the volume of box D is subtracted from the volume of box C is 23 and 14 hundredths cubic centimeters. Box D has a volume of 10 and 115 thousandths cubic centimeters. So the first thing we have to do for A, it says, let C be the volume of box C in cubic centimeters. Write an equation that can be used to determine the volume of box C. So I have to take what I just read and put it into an equation. And I know that they gave me box D, and I know I have to subtract box D from C, so I'm going to put C minus. And then it would be box D, and I know the value is right here. So if I subtract this, I'm going to end up with that, 23 and 14 hundredths centimeters cubed. So that's A. Now, what we have to do is, for B, solve the equation to determine the volume of box C. I'm going to zoom in for this one so I can get a little bit more space. So I have C minus 10 and 115,000 centimeters cubed equals 23 and 14 hundredths centimeters cubed. Now, I'm going to show it vertically. You can show it horizontally or whichever way you would like. So I have to now get C by itself. I want to isolate the variable, get it by itself, and I'm going to do that by, I know that if I have C and I subtract a number and then add the same number to it, I'm just going to get C. So if I'm subtracting this 10 and 115 thousandths, if I add it, it's going to go away. I'll just be left with C. Now, what I do to one side of the equation, I have to do to the other side to keep the equation equivalent. So if I added this 10 and 115 thousandths, I have to do it over here as well. And another way that I could show this, and I'm going to show it to you this way as well, just so you, those of you that are using a different method, I could then add the 10 and 50 thousandths, and that's going to equal 23 and 14 hundredths plus 10 and 115 thousandths. And I got to put my units in still. But that's a way that I can show when I subtract something and then add the same thing, they cancel out. And then I have to show that if I'm adding the 10 and 115 thousandths to one side, I have to do it to the other side of the equation. I know some of you possibly draw the line straight down to show the two sides of the equation. That's fine. But I wanted to show this, what this equation would look like, as well as this equation over here. And either one is good. So now I have C equals, and I'm just going to add these. And I know that I got to have a placeholder. And I'm still talking in terms of centimeters cubed. So I'm just going to add, and I can't forget my decimal point. I'm bringing it straight down. And it looks like I'm going to get C equals 33 and 255 thousandths centimeters cubed. And that's what C is going to equal. So quite a bit of work for that. But now on to part C, and it says the volume of box C is 1/10 the volume of another box E. Let E represent the volume of box E in cubic centimeters. Write an equation that could be used to determine the volume of box E using the result from part B. So, the volume of box C is 1/10 the volume of box E. So if I take 1/10 of E, I'm going to get the answer for C, which I got right here. So 1/10 of E should get me 33 and 255 thousandths centimeters cubed. And I already know what I have to do for D. I'm going to have to solve this one. So that's what you'll do for D. Thanks for watching, and good luck with the rest of your problem set.